As I said before, it's not feasible to check every possible line, even with a really, really fast computer. What we have to do instead is somehow allow the data to speak to us, allow the data to decide where the lines are. And because this is democracy, what are we going to do? Well, we're going to do something called voting. So voting is a general technique where we let the features vote for all the models that are compatible with it. And the way it works is pretty straightforward. We cycle through all the features. Now, today, for mostly features, what I'm going to mean is little edge points, all right? And each edge point is going to cast a vote for the model parameters or the different sets of model parameters that it's happy with or consistent with. And when we're all done, we look for the model parameters that receive a lot of votes. And those are the parameter models that we're going to instantiate. Why does voting work? Well, voting works for the same reason that Mickey Mouse, Donald Duck, and Lara Croft are never elected governor of California. Angelina Jolie, maybe, but not Lara Croft. You see, what happens is, in every election, there are people. There could be millions of people who are unhappy with the main candidates, the real candidates, if you will, and they'll write in some silly name, Mickey Mouse or Lara Croft. But even if there are millions of silly votes, as long as they don't all put down the same silly name, then in some sense a real candidate will get elected. And this will work unless Stephen Colbert or somebody like that tries to orchestrate an overthrow. But in general, the idea is that these silly votes are all distributed across sort of the not important candidate. So this works the same way for our computer vision. Noise and clutter features will cast votes too, just like the real features, but typically their votes should be inconsistent with the majority of the good features. Also, another nice thing is, even if part of the circle, say, is occluded and there are no features there to vote for it, because the rest of the circle has gotten a lot of votes, we're able to find the circle. So the example we're going to use today to start with is just on fitting lines. All right? And to fit lines, we're going to have to ask a couple of questions. First of all, given points that belong to a line, what is the line? That is, you know, which line are they picking? How many lines are there? And which points belong to which lines? Now, we're mostly going to focus on the first question for this lecture, and in fact, most of what we'll do. But extensions to what we're talking about make it easy to do questions 2 and 3 as well. So the method that we're going to talk about today is called the Hough transform. And it's a voting technique that can be used to answer all these questions. And the main idea is just that voting principle. Each edge point is going to vote for compatible lines. That is, it's going to vote for any line that would go through it. And then you look for the lines that get many votes. So there might be 2, 3, 4 lines, and you can find all of them. And by the way, if you keep track of which points voted for which lines, you're also able to go back and say which points belong to that line.